Welcome to the Crazy Hat Chemist. So another video here on solubility. So let's get moving. Bam! So we're talking about solubility example number 3. We're going to determine the solubility of barium sulfate. The Ksp for barium sulfate is 1.1 times 10 to the negative 10 at 25 degrees Celsius. Remember, K values are temperature dependent. Therefore, the 25 degrees Celsius is incorporated in there. Furthermore, if you look up these values in the back of your textbook, in the appendix, or in the chemistry or the handbook of chemistry and physics, you will find that these are all at 25 degrees Celsius or 298 Kelvin. Now, we first need to figure out what the formula for barium sulfate is. Barium is a periodic trend charge of a 2+ ion because it's in group 2. Sulfate is a polyatomic ion. That's SO4 with a 2- charge. We're going to put those two things together and we're going to get BaSO4 1-to-1 ratio and the 2's disappear. So let's do this. So we got barium sulfate. That is a solid because this is an insoluble precipitate. Notice again the equilibrium arrows lie predominantly on the reactant side, and you can notice that by the Ksp value, which is 1.1 times 10 to the negative 10. That indicates that it is certainly reactant favored. Okay, that is, this is an insoluble precipitate. Okay, then on the product side, I have a barium ion, a 2+, that's aqueous, and a sulfate ion, that's a polyatomic ion, that's a 2-, that is also aqueous. I'm going to do an ice table for that. That is initial change and equilibrium. Again, for the barium sulfate, that's a solid, I'm not going to worry about that because that's a solid, and solids are not included in K expressions of any kind. Okay, what are on the reactant side? Initially, just like all equilibrium reactions, that's a 0 and that's a 0. In regards to the change, I don't need to worry about the barium sulfate, get rid of that as well. Okay, but the barium ion and the sulfate ion, I'm looking at the stoichiometric coefficients on the balanced equation, both of which are 1s. So it's going to shift towards the product, so that's a plus. So a plus 1x for the barium ion and a plus 1x for the sulfate ion. I'm going to add up the initial and the change columns, and I'm going to get my equilibrium here. And that equilibrium, again, nothing for the barium sulfate, but I'm going to have an x, that's a 1x for the barium ion, and an x, that's a 1x for the sulfate ion. Okay. Now what we're going to do is we're going to write our Ksp expression for this. That is products over reactants, stoichiometric coefficients as exponents. Solids are not included, and here's my Ksp expression. Ksp is equal to the barium ion, in brackets, aqueous, 2+, exponent of a 1, sulfate ion, that's an SO4 2-, that's aqueous, exponent of a 1 as well. Okay, so what am I going to do and plug into this? So I do have the Ksp that was given to me in the problem. That's 1.1 times 10 to the negative 10. I'm going to substitute that in for the Ksp, that numeric value that is. And the x is on the equilibrium section here. The first x is for the barium ion. I'm going to plug that into that Ksp expression. That second x right over there is for the sulfate ion, and I'm going to plug that in. So after plugging those in, substituting in there, I'm going to get 1.1 times 10 to the negative 10. That is substituted in for the Ksp is equal to x times x. The first x is the barium, second x is the sulfate. I'm going to simplify this just a little bit here, and x times x is equal to x squared. So I have 1.1 times 10 to the negative 10 is equal to x squared. I'm solving for x, so I'm going to square root both sides. Okay, so I'm going to square root the 1.1 times 10 to the negative 10. That's equal to x. Plug that into my calculator, and I'm going to get this value right here. I've just solved for x. X is equal to 1.0 times 10 to the negative 5. Okay, that is equal to the solubility. Since this is x, I just solved for the solubility. Okay, what does that mean really? That means that x is equal to the barium ion. I'm looking back at that equilibrium, what I've highlighted in the blue. And x is also equal to the sulfate ion. And that value is equal to 1.0 times 10 to the negative 5 molar. So now I have the solubility of barium sulfate at 25 degrees Celsius. I'm going to add just a little bit more to this problem here to add a little bit more spice. Okay, so what is the solubility in grams per liter? Okay, now I have the molarity, which is moles per liter. I need to convert this into grams per liter. Okay, it's really simple. I'm going to be using the molar mass for barium sulfate, but I'm going to take this 1.0 times 10 to the negative 5 and understand that this is moles per liter. So I've just converted that to moles per liter and then multiplied by the molar mass. Okay, you should see that the moles cancels out. You're left with now grams per liter. And the actual value here, plugging this into my calculator, I got 2.3 times 10 to the negative 3 grams of barium sulfate per liter. That is the solubility in grams per liter for barium sulfate. That's a little bit more sugar and spice to your life. Everybody needs that. Okay, I am the Crazy Hat Chemist, and of course, it can't go away without having a crazy hat, and I graduated from this place. Okay, I'm a Hornet. Guess where that is? It's at least one of the places that I have graduated from. And that is, figure it out for yourself. Okay? Don't forget to give me a thumbs up on that video, subscribe to my YouTube channel, and don't forget to get yourself a sticker by donating to my website. Really appreciate that. Truly do. It takes a lot of time and effort to make these videos just for you so that you can understand how to do complex chemistry problems. I'm here for you. Talk to you later. Bye for now.